What if I told you that a fundamental rule of our world, a truth we've accepted for over 2,000 years, was actually built on a lie? Well, today we're going to unravel that very lie. I mean, really think about that for a second. What if the very fabric of space and time around you was based on a simple, ancient misunderstanding? And no, this isn't some sci-fi plot. This is the real story of one of the greatest revolutions in the history of mathematics.
All right, so to get to the bottom of this, we've got to go way, way back. Our story kicks off in ancient Greece, with what seemed like a tiny, almost invisible crack in the very foundation of geometry.
This is the rule at the heart of it all, Euclid's fifth postulate. And honestly, it sounds incredibly straightforward, right? You draw a line, you put a dot next to it. The rule just says you can only draw one single line through that dot that will never, ever touch the first one. It seems so obvious. It just feels right. And because of that, it was simply accepted as fact. But, and this is a huge but, this is where the mystery really begins. For 2,000 years, the greatest minds on the planet tried to prove this obvious rule, and every single one of them failed. It was the ultimate mathematical puzzle. See, it wasn't that they thought it was wrong. They just couldn't figure out why it was true. It was like this intellectual itch that humanity just could not scratch.
So after 2,000 years of failure, you'd think people would just move on. But then, along came our heroes, the rebels of mathematics who decided to take a completely different and far more dangerous path.
Meet Nikolai Lobachevsky and János Bolyai. In the early 1800s, working completely unaware of each other, they both got fed up with the same old problem. They were tired of trying to prove a rule that simply refused to be proven, and they decided to do something no one had ever dared to do.
They asked a revolutionary question, a question that would change everything. They said, what if we stop trying to prove it? What if the rule is simply wrong? You have to understand, in the rigid world of mathematics, this wasn't just a new idea. This was an act of full-blown rebellion.
So to test this dangerous idea, they conducted a thought experiment, one that would end up reshaping our understanding of reality itself.
Okay, let's walk through this together. First, forget about a flat piece of paper. Imagine a surface that curves in two directions, kind of like a horse's saddle. Got it? Okay. Next, draw a huge triangle on this warped surface. And finally, you measure its three internal angles and add them all up.
Now, we all learned in school that on a flat surface, the angles of a triangle always add up to exactly 180 degrees, no exceptions. That's the bedrock of geometry as we know it. So the expectation was that the result would be the same on the saddle, right? But when they actually did the math, what did they find? Did their calculations confirm the 2,000-year-old rule? Not a chance. The result was shocking. The angles of the triangle on the saddle added up to 165 degrees, less than 180. And the bigger they made the triangle, the smaller the sum became. This should have been impossible. By all known logic, this was a failure, but it was a failure that changed everything.
Because that single result didn't break math. It threw open the door to an entirely new reality. A reality that wasn't flat.
And what's so cool is seeing them side by side like this. On the left, you've got our familiar Euclidean geometry. A flat world, triangles are 180 degrees, and you only get one parallel line. But on the right, you have this new reality they discovered, hyperbolic geometry. Here, the surface is curved. A triangle's angles add up to less than 180, and, get this, through a single point, you can draw an infinite number of parallel lines. It's wild.
So the crucial point is this. Their experiment didn't fail. It wasn't a mistake at all. It was the discovery of an entirely new mathematical universe that was perfectly logical and consistent on its own terms. They had proven that Euclid's flat world wasn't the only reality.
For decades, this discovery was seen as just a mathematical curiosity, a weird alternative reality with no real-world use. Then one man came along and showed that this bizarre geometry was actually the language of our cosmos.
Let's just trace this incredible journey. Around 300 BCE, Euclid lays down the rules for flat geometry. Then silence for over 2,000 years, until 1830, when Lobachevsky and Bolyai opened the door to curved geometry. And then, boom, less than 100 years later, in 1915, Albert Einstein grabs their weird math to describe his theory of general relativity. And today, that very same geometry is sitting in your hand, powering your GPS.
And this is the brilliant part. Einstein proved that massive objects like planets and stars don't just sit in space. They literally bend and warp the fabric of spacetime into the exact kinds of non-Euclidean curves that Lobachevsky and Bolyai had imagined. What we experience as gravity, it turns out, is just the shape of this curved space.
So why does any of this matter to you? Well, the satellites that make your GPS work are orbiting through that curved space-time around Earth. Because of this curve, their clocks actually tick at a slightly different rate than ours on the ground. To give you an accurate location, the system has to constantly use non-Euclidean geometry to correct for this warp. Without it, your GPS would be off by several miles every single day. It'd be useless.
This story just shows us that having the courage to question a truth can fundamentally change reality. Which leaves you with a final thought. What so-called unbreakable rules of our world today are just waiting for their own rebels to come along and break them?